My name is Meghan Sloan. I am a data science and reporting manager at Uplight. My undergrad is in biochemistry, but I went into Teach for America right after college, and I taught middle school for 2 years and got my master's in education. But I missed being in the lab. I missed the science. So I went back and did all kinds of research, education research, lung cancer research, taste research. And then finally, I ended up in a DNA sequencing lab. And genomic data is big. You need data science tools to handle it. That's where I started coding to handle big data and to interpret data and to build models around data. And that's where I realized, ooh, this is fun. I took a bioinformatics class while I was there and thought, how do I do more of this? That's when I got my data science certificate, ended up at Tendril, which is now Uplight, and I've been there ever since. I think the most important thing is don't be afraid to ask questions. Ask questions. Everybody's new. Even if you've been doing something for 20 years, you're still going to have questions. Things change. It's a fast-moving world. Keep asking questions. That is really important. People don't expect you to know every single answer. They don't expect you to know everything. It's okay to ask questions. If it's not okay to ask questions, I don't think you want to work there anyways. Uplight partners with utilities to help them manage grid demand. And so I'll give an example. In the summer, the hottest days, hottest time of the day, there's huge demand on the grid. Utilities are required to meet that demand 24/7 and do it safely. But it is very expensive to meet that peak demand when everybody has their air conditioners running. In order to do so, generally, utilities have to fire up fossil fuel, expensive electricity generators to meet that demand. They don't want to do that. It is expensive. They don't want to build power plants to support just an hour of the hottest days of the summer. So if we can shift the demand to an earlier part of the day, then they don't have to depend on those very expensive power plants, and our software helps them move that load to different times of the day. The world has a lot of data now. We've collected a lot of data, and we can use that data to build models in order to explain the data. And then those models are useful because it allows us to predict the unknown. So for example, it helps us predict how much energy homes are going to consume the next day or at the hottest hour of the day, or whether or not someone has a propensity to buy an electric vehicle. We can, based on existing data, we can build a model to predict about things where we're less certain, and we want to know what's going to happen, and we need to have a good idea of what's going to happen. From a data science perspective, we are a Databricks shop at Uplight. So the typical life of a data scientist is to log into Databricks, spin up a compute cluster, look at data, and then depending where they are in the project, they will do some evaluation of the data to see, is it good, and start building proof of concept models and experimenting with those models. What features explain the data the best? What gives us the best predictions? They build evaluation frameworks to determine, is this a good model? And also they work on defining, how do we know if this is a good model? So that's a lot of our work. And then once we have a model that we feel really good about, we partner very closely with engineering teams to stand that model up in a production system. So we have a pipeline of data flowing in, data flowing out, and the model is part of that system. I didn't build this particular model, but I managed the team that built it, was the EV detection model. This has impact for utilities because EVs are great. You don't have to charge it in the middle of the afternoon when it's the hottest and everybody's running their air conditioner. So we talked about trying to move demand away from those time periods when the grid has the highest demand. EVs are great. You just charge them at night, but not everybody knows to just charge them at night. They don't know that they're helping the grid doing so, or that in some cases it's cheaper to do so. And utilities don't know where the electric vehicles are. We have an electric vehicle detection model that will identify households that we think have a high probability of having an EV based on their consumption patterns. And so that helps the utility reach out and say, hey, don't charge during the middle of the afternoon, charge at night. And sometimes can even incentivize utilities to do so. Communication is really important because we are a virtual first organization. Documentation is really important. Clear documentation, clear communication, clear knowledge transfer sessions. We do a lot of that on the data science team because ultimately an engineering team is going to own the process where the model is. And so having very clear understanding of how it works, what the inputs are, what the requirements are, having very, very clear communication is something that we work really hard on. From a technical skill perspective, I think it is important to know your data science. You don't have to use it every day, but you should be able to defend what you are doing and make good choices about it. So know your statistics, know how to model, know how to code. Even though there are amazing tools now that help us, you can just go ask ChatGPT, hey, write up some code for me. If you don't know the fundamentals, you're not going to know when ChatGPT gets it wrong, and it does a lot of the time. It is not perfect. It needs guidance. My advice from a technical perspective is know your fundamentals so that you can double check, and you can contribute, and you can evaluate others' work as well. I think a huge aspect of software development is the review process. So you can be beneficial to your teammates as well as reviewing their code. So yep, knowing your fundamentals in data science is really important. I love the idea of apprenticeship. Maybe it's just how I learn. I think the best way to learn how to do something is to do it, to practice it, to try it, and to have someone who is guiding you through that process. That's the way you're going to learn. So having an apprenticeship program, I think, makes a ton of sense. Those who go through an apprenticeship program are more likely to stay at the company. They're more likely to stay long term. They're invested in the company. It's mutually beneficial. You invest time in training, but you're getting back someone who is invested in the company and will stay long term, which is great. In Boulder, where I am, there are 3 different women in data science groups. There's women in AI, there's women in machine learning and data science, and there's women in data science. And I believe those are all national groups. So you just find your local chapter, connect with them on Meetup, find them, go to those groups. I've found them to be super supportive, very interesting, and you start to build your community that way. I'm also part of the Women in Clean Tech group. That is a global community, but I just joined our local chapter here. So there are all kinds of groups. Start talking to people, start meeting people, lots of free classes, all sorts of interesting things. YouTube University really is amazing. There are lots of opportunities for mentorship, and then also seek out people if your place of employment has. We just launched a mentorship program at Uplight, and we also have employee resource group for various communities so that people can get together and talk about their challenges and support one another. So those are all great resources if you have them. I feel really fortunate, actually. I've worked for a lot of women in science and tech. Most of my managers and mentors have been women. I feel very supported from female and male colleagues, so I do feel really fortunate in that regard. In hindsight, looking back, there were some moments of, going through classes or a certificate program that I I definitely had imposter syndrome. I think everybody gets that when they're doing something new, like, and that feeling of, ooh, I shouldn't be here. I don't know what I'm doing. I don't belong here. And just trying to get over your internal monologue to say, like, you can do this. It's okay. You just have to learn it, and just be open with people about what you know and what you don't know, and continue to ask a lot of questions. I think if you're changing careers and you're wanting to get into data science, there are a few things. One, it is changing so fast, like exponentially fast. When I started, it was already changing fast, and now 8 years in, it is like, wow, things are changing fast, especially with generative AI, etc. On the other hand, like, I still think that those fundamentals are key. As you're trying to get into the industry and you want to get a job doing these things, while you are looking for a job, be working on something, right? Reach out to people, offer to do pro bono work for them, get your hands dirty. That is why I think an apprenticeship program is so great. Again, like, learn by doing and show that you know how to do it. And so if you do something on your own and you say, hey, I built this project and I built this model to do XYZ things, find your local women in machine learning and data science class or group, whatever it is, and then present your project there. I think the more that you can do and keep using your skills and actually put them into practice, that is a step that frankly a lot of people don't take. A lot of people come and say, ooh, how do I get into data science? And I tell them the same thing, and nobody takes me up on it. And so I think the point is that keep reaching out, keep practicing, keep trying, and keep pushing for it. If you really want to do it, you will have an innate desire to say, ooh, I could build this thing, let me try. And you might fail, it might not work. That's okay. At least you are trying, you are learning, you're building those skills. Be innately interested in it, seek out that information, and put it to good use while you are looking for a job. I think that's just going to enhance your job search and what you can tell people on your resume in the interview process. People want to see, what experience do you actually have using data, looking at data. Data's messy. How do you deal with it? How do you handle it? How do you build a model? How do you choose your features? All of that. What's exciting is, I think historically the energy industry has been very conservative, as they should be. They're trying to provide safe, reliable energy every hour of the day, all the time. But we are at a point where maybe we can't take that approach anymore. We need to be a little bit more nuanced, and we need to do things potentially on a household level, which is a lot of data. It is a lot of interacting, moving parts, and you cannot do that without data science. So I think it's an exciting time to be in data science and in energy efficiency, and solving these problems. There are cost problems, and there has never been such high demand on the grid, and climate change is real, and we need to solve it. And I think data science and data in general, it is going to help solve those problems. So that's exciting.